Thank you for coming to this session. This is common security vulnerabilities you wish your application didn't have. My name's Simon Maple. I'm from a company called Snick, a company that deals with security vulnerabilities, security issues in third-party dependencies. And we're going to go through a whole bunch of different applications, real-world libraries. We're going to hack them. You're going to hack them. But we're not going to do it on live sites, obviously, because that's illegal. So we're going to do that on an application which we've crafted using real libraries. You're going to help me hack this, and we're going to determine where the vulnerabilities exist and how we can break them. If you wanted to follow me on Twitter, I today just passed 10,000 Twitter followers, so yay, go me. Feel free to SJ Maple up there. A little bit, oh no, it's just not working. Never mind. A little bit about me. Oh, it's not on, I bet. Yeah, there we go. There we go. A little bit about me. So I work in the DevRel team at Snick. I have a history of Java for about 20 years now, and I used to work for IBM as a developer on WebSphere. Any WebSphere users? And I say users like it's a drug. Then I moved over to Zero Turnaround. Any JRebel users? Not many. One. And now I'm at Snick. I've been here for a few months now. I'm probably most well known for the virtual jug, although I also do a bunch of work with the London jug as well. And there's a bunch of other stuff there which I got. So we'll talk about DevSecOps first. Who's heard of DevSecOps? It's quite hard to see the audience here. A few people. Who's heard of DevOps? Loads of people. And everyone else, the rest of everyone just has broken arms right now or something, right? Because I'm sure everyone's heard of DevOps. So DevOps, yeah, it's a new way of delivering software faster, mixing developers and operations. Security, they thought, well, how can we get in on this? I know, we'll put sec between the dev and the ops. There we go, DevSecOps. And they've created some cool new term, and it's really about trying to pull security into the existing workflow of development and DevOps. The problems that exist as to why we need something like DevSecOps, well, first of all, the deliverables which we have in our software development is typically too feature-oriented. So when we think about new features, we always think about what needs to be done. What needs to be done for this to be an accurate feature, for this to actually deliver on the feature requirements. We don't think necessarily too much about security or performance or other things like that. When we over the last particularly 5-10 years, we've tried to speed up our software delivery. We've tried to be more agile, have iterations or sprints of about 1, 2, 3 weeks. And we've tried to deliver to production very, very quickly. Who delivers every day to production? One. Anyone else? Maybe. There we go. A couple of people. So when we deliver every day to production, how do we keep security practices in? How do we make sure we don't have new vulnerabilities? How do we make sure all our testing is done for every single build? There is a lack of security focus through the application pipeline, and as a result, security is traditionally done as maybe audits every quarter, year. Who does audits here? Security audits? Like 3 hands, 4 hands, a couple more now. Ultimately, the organization's reputation's on the line. Customer data is at risk. We all hear the stories about customer data being breached, and we don't want it to happen to us, but are we putting the necessary steps in place to stop those breaches? So let's take a look at how bad the situation is. What is the problem? Well, we know that if we look at packages in Maven Central, 59% remain unfixed. So these are known vulnerabilities. We can just take a look at who's heard of Equifax. Oh, only a few people. Okay. Equifax are pretty well known for all the wrong reasons. Equifax used Struts 2, and there was a major Struts 2 breach which occurred in the Equifax application, which means that remote code execution was possible on the Equifax machines. I'll show you this actually running live, but yeah, this was a major breach in Struts. And if we actually look at the Equifax timeline, it's quite interesting because there was an amount of time that Equifax didn't even realize they were breached for. Equifax were very slow in updating their dependencies. And what's interesting to me is when we look at the Struts 2 hacking kind of timeline, you can see that the vulnerability was known about. There was a huge number of attackers targeting that vulnerability. And they target the vulnerability, they target the open source vulnerability, because, and I'm going to mention this a few times, one open source target has many, many victims. So let's pick on JavaScript because it's more fun. If we look at NPM, the usage of NPM has exploded. 400,000 packages downloaded every single day, I believe. 400,000 packages, that is actually increased now up to 600,000 packages. Pardon me. Those are just packages that are existing in Maven Central. So the number of packages that have indexed, 400,000. 6 billion downloads per month. And also over 70,000 publishers, people that are actually providing packages into NPM. If we actually look at your application, when we think about those dependencies that get pulled in, there are two parts. There's your code, the code you actually write, and there's the code which you actually pull into your application. We deploy the whole thing. But when we actually write code and think about the security of the code, we very often think about the security in this kind of purple piece in the middle, the code which we write. But what about this huge area of code which we're actually deploying? Isn't it great that we can write just a small piece of purple code and actually make use of all this third-party code? Let's take a serverless example. This is 19 lines of code. It's just a piece of code which grabs a file and stores it in S3. 19 lines of code, two dependencies, two direct dependencies, which means if we look at our dependency tree, we are making use of two dependencies specifically, explicitly. How many dependencies in total, including transitive dependencies and direct dependencies, do you think we have in this application? Just a guess. 50, and I think I heard 20,000, but I'm not sure. 50, any other guesses? 400. In this case, it's only about 19, which is quite surprising because very often when you look at things like Node and stuff like that, you do get a very large number of dependencies. So 19 lines of code, two direct dependencies, 19 transitive dependencies. How many lines of code do you think in total would be in this application? 100? 100,000? 10,000. Any other guesses? Bigger? Think big. 100,000. Double it. Almost 200,000 lines of code. Okay? So when you're writing your code and you write 19 lines of code and you add a couple of dependencies, don't think about the fact that you're deploying 19 lines of code. Think about that your application is going to be almost 200,000 lines of code big, okay, when you deploy. And this is crucial because a lot of the testing we do, we typically run across our code. But we must think about the dependencies. Who knows how many direct dependencies their applications have? One person. How do you know that, sir? It's in the list? That's direct dependencies, yeah? Do you know how many indirect dependencies you have? Say again? Maven 3 list, right. Anyone else done that? Couple of people. How many dependencies do you have then in total? You don't know, right? One of the things that we think about with our application, we think about our code directly. We don't think about how many dependencies are in our code, what vulnerabilities exist in that code, because the vulnerabilities are typically going to exist in our open source code, because the open source code is the code that attackers are targeting. So let's throw some numbers at you. Open source, how bad is the state? Well, when we think about the growth of the industry, and by the way, these numbers are actually created through an amount of research as well as surveys, which Snick has done. We look at NPM. NPM has almost grown year on year by almost 60%. Okay. Maven, if we look at Maven Central, the number of packages and libraries that have been introduced into Maven has grown by 30% year on year. This is October 2016 to October 2017. So the growth is huge. When we think about the number of sites that have a single library that has a known vulnerability, a single or more libraries that have known vulnerabilities, what percentage of 430,000 sites do you think we tested that have at least one known vulnerability in a front-end library? 99? Any others? 40. There's always one optimist with 99, isn't there? 77. About 3/4 have at least one vulnerability. Okay? Here's something that Java is going to win over Node. The number of critical Java and Node package vulnerabilities, Java is winning this race easily. We can see how it's increased from 2014. But if we actually look at the number of open source vulnerabilities, we see this kind of exponential graph. Everyone's seen that nice meme about how the words exponential graph has been used exponentially over time? That's a good one. So we can see the number of vulnerabilities in open source code has increased massively. Okay, there's a reason for this. Two reasons. First of all, open source has massively increased. Okay, if we think about open source, even Microsoft are using open source heavily right now. Microsoft's bought GitHub, right? And you know the transformation has occurred when Microsoft are buying GitHub and Microsoft are adopting open source code. Okay, open source is here and it's here to stay, and it's great to see Microsoft also leading that. The second thing is with open source code, like I said, one vulnerability. You're not just attacking one site. Everyone who uses that library everyone who uses that library can therefore be attacked if a vulnerability exists in that open source code. How about maintainers? So maintainers tend to react very, very quickly. The median time is just over 2 weeks from a maintainer to find a bug to actually fix that bug. But the time that a vulnerability exists in code is quite actually a lot longer. 2.5 years before a bug has been introduced into code to actually being found. Docker is some kind of cool new technology, so that can't have vulnerabilities yet, surely. What percentage of the top 1,000 images, containers, have known vulnerabilities? What do you think? 98. Beautiful British accent, 98. 76.6, about 3/4. So what we're saying here, open source usage has exploded. We're not saying open source isn't secure. It's as secure as kind of other software, your proprietary code, perhaps even more secure than proprietary code because it has more eyes looking over the code. But attackers are targeting it, and they're targeting it because one vulnerability has many victims. So, enough talking. Let's start hacking. I'm going to show you a few examples of some hacks. We're going to look through a number of vulnerabilities, some Java vulnerabilities, some Node vulnerabilities. We're not too bothered about what the actual implementation of your code is. We're more focused on the vulnerabilities that can exist in any ecosystem. So I'll be showing you a number of apps with vulnerabilities. Who's a Spring user here? A whole bunch of people. So if we include everyone with the broken arms, you're probably looking at about 60–70%. Who's a Spring Data user? Who's a Spring Data REST user? So there's about 6, 7, 8 people. So double that up to about 15, 16. Who's heard of Spring Break? No one. This always happens. One person at the back there. So Spring Break was something that came out, something that was discovered a number of months ago, only a few months ago. And it's a remote code execution which can occur against certain versions of a package in Spring Data REST. Let me show you a very quick example of what Spring Data REST is. So Spring Data REST, let me open Spring Goof. So Spring Data REST, Spring Data, for those of you who aren't aware of Spring Data allows you to have access to backends in a implementation agnostic way. So I can just write some code against my repository interfaces, and as a result, the backend code will be written for me to access the databases. And irrespective of the backend I'm using, my interface is going to be very, very similar. As a result, what I have is these domain objects. In this case, I just have a grocery application. This grocery application is going to have it's going to have the name of the grocery, and it's going to have the cost of the grocery as a string and a double. So very, very straightforward. I'm also going to have an item repository. It's going to extend a CRUD repository, so this is going to give me all my CRUD functions. And whatever methods I add here into this interface is going to be automatically implemented for me by Spring Data. Great. The other thing I'm adding here to add Spring Data REST is this repository REST resource annotation. And what this annotation is going to do is it's going to allow me runtime access via RESTful web service calls to those domain objects, to the state that's in that server. So let me show you this running, and then I'll show you the hack. So we have Spring Break here. And Spring Break, this is just obviously the Explorer view. Spring Break, I can view if I view items. I view my response body. Items is my domain object, and here I can see a number of items that are already been added. So I have beans at 50p, milk at £1.09, and so forth, with bread, sausages, and so forth. If I wanted to choose a specific one, that we just get that one. Sausages are almost a fiver. So we get this information. But one thing that we can do, because we're exposing this as a RESTful endpoint, is we can actually, let me go across to here and see where we are. We're in Java Goof, so I want to be in Spring Goof and into the exploits. And one thing I should say is actually all of this code is available on GitHub, so you can actually download, run the apps, and exploit them yourself as well. Now, the code which I'm going to show you is going to be in the exploit JSON. And this specific code is the payload which is required, which goes into the request. And this is effectively going to allow us to get the runtime. Can you see that okay? Exactly, yep. So it's going to allow us to get the runtime, and it's going to allow us to pretty much execute what we want on that. So I'm going to here substitute this command for whatever command I would like. And then all we do is if I was to cat the spring rest exploit / let's do password, I'm going to curl this, and you can see that what we're doing instead of that command is we're going to we're going to cat, we're going to grab the etc. and password, and we're going to return that as an input stream back to us here. The only thing I'm going to do is I'm going to change this from being my local host, and I'm going to copy paste this application and like this. So we're making an invocation to the item/1 endpoint. We're adding that as part of our header. I run that, and all of a sudden we get the etc. password from that machine. And this is obviously from here. This is a machine running on Pivotal Cloud Foundry. Okay, so all of a sudden we can get that information. Etc. password, not massively useful these days, but you can see which users are being run here. What might be more interesting is if we were to start catting certain config files and things like that. Let me show you another example. If I was to cat the env, and I'm going to grab this now, copy paste this, remove my local host, and grab this URL again. And what we're going to do here is we're going to actually access the environment variable. So all we're doing is execing env. I run that and we get the environment variables. Who stores usernames and passwords in their environment variables? Own up, yeah, there we go, a few people, right? So all of a sudden you can gather information about your system. From here, in fact, I'll show you the Struts example and we'll have a little bit more of a play. But when you gather information about the system, you know, the first hack might not actually be your breach. The first hack might just be the way into the system, so you can find a new hack which gives you better permissions or more information and so forth. So here we can start looking around the system, understanding what it's connected to, understanding which databases are, what the configurations are, you know, what usernames, passwords perhaps are, which you know very often find in things like environment files. Any questions so far? You have to shout out because I can barely see you. No, awesome. Okay, let's move over to Struts. Any Struts users here? One Struts user right at the front. Okay, awesome. So you're using Struts 2, I presume? Struts 1, wow. Things are bad. Okay. Right, so let's show you, so Struts, I have got, oh, actually I think I've got Struts on Heroku, yes. So this is my, if I come back over here, this is my Struts application, so I have something called Java Goof. I need to sign up. So let me sign up quickly. So Simon, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, yes. I work for a security company. See, one password, look, see. So this is my to-do list. I can click around. I can create a to-do, perhaps. In my to-do, there's a whole bunch of things here. I could buy my wife flowers. That would be nice. Let's do it in 1970. Let's make that high, because I haven't done it for a while. And there we have a to-do. So it's just a normal to-do app. One thing which I'm going to show you here is the about, where we can see we're using Struts 2 at version 2.3. We're using Spring at quite an old version, 3.2. And we're using Hibernate, because I like to make bad life decisions. So what I'm going to do now is I'm going to exploit Struts. And the way I'm going to do so is I'm going to come out, where am I here? I'm in Spring Goof still. So I'm going to come out of that. I'm going to run the, it's in Java goof, exploits, and in here, we have the magic incarnation, which is this one. And this is the header, and both Spring Break and Struts 2 both have something very critical in common, that you don't actually require a setup in order to breach these or hack these. It just needs to exist at a certain version, and then you call an endpoint with a specific header. So it's a very critical vulnerability, because you don't need to do anything other than send a specific payload in a header. This is the payload for Struts, and it's actually an interesting payload, because what it does is it traverses through and finds an exception path. And when you go down an exception path, hackers love exception paths, because when you go down an exception path, checks aren't made, validations aren't made, you get into certain states which maybe developers don't expect, and all of a sudden you might have more control than you think. So what actually happens is code was executed here because we went down an exception path, and I believe on e.getMessage, that's when we actually run certain remote code. So to run this, and you can run this online again, what I'm going to do is I'm going to cat this file here. And we have a couple of things here, so I'm going to, well, we've shown you the password already. Let me show you in fact, what I can do is, I think I'm running this on Heroku, so let me go over to Heroku, grab this. Let's see if this works. I'm going to come over here, and we're going to exploit headers. So we're catting that out. We're substituting the command word for env. I run that. And all of a sudden we get, did we get that? Did that work? That didn't work. Let me run this locally. I have this application locally as well. There we go. So we have our environment variables here. From here, we can pretty much run what we want. I mean, if I wanted to come here and change the /env invocation here, I can perhaps have a look at the ls-l. So I run that, and did we get it? Oh, weird, this isn't working anymore. That's frustrating. Well, this is local host, though, so I'm... It is working on the remote server. Oh, it was working on the remote server, but not the local. Oh, yes, there we go. Okay, so let's do that again. But this time we'll do it ls-l. And we should hopefully be able to then see... There we go. All of a sudden, we get a directory listing of our runtime. We can also do other things. We can, at this point, then start catting. At this point, start catting a whole bunch of different interesting files that we find. Other things we can do. We can have a look at what processes are perhaps running on that server. We can grab information from that server. So very similar to the kind of Spring exploit, but that's it. One other thing I want to show you before we finish off with this Heroku app is something called ZipSlip, which is a vulnerability which we disclosed. Well, we didn't disclose it. We found a huge number of instances of what we've dubbed as ZipSlip, which is a compress vulnerability which has directory traversal in it. So who's heard of ZipSlip since we disclosed it? Okay, quite a few people. Awesome. So let me show you, first of all, what it is. So if I click on My Files, currently we have no files in the public folder, but what I can do is I can upload zip files which will then be exploded on my Heroku server. Now, if I was to create a to-do, I can maybe create something with non-ASCII characters like eat pie. And if I click on eat pie with a due date of whenever and click create, This is going to run through a actual tool in the JVM. We're actually going to do a remote execution of native to ASCII, which takes native characters, non-ASCII characters, and gives an ASCII representation like this, which is pi. Let me show you that actual code. So if I come through over to oops, web struts to do action and do upload. At this point, when we actually do the upload, we call unpack from the zip util. The zip util is actually a zero turnaround ZT zip package. And so at this point, all we're going to do is just a basic unstruct. This is a basic extract. This is all library code. The thing which is going to be interesting, where I mentioned where we call the native to ASCII, every time we set the title on my to-do, we call this native to ASCII method, which runs a remote process, which is native to ASCII. It's the Java home native to ASCII invocations. This is making a remote request out to make that invocation. Okay, so that's where this happens, and if I was to go back to my shell, you'll be able to see at this point we run native to ASCII, and we've done a conversion from eat pi to eat the ASCII equivalent of pi. Now, what I'm going to do is I'm going to extract a new file, and this file is in the exploits. I'm going to jar minus tvf of zipslip.zip, and if I show you what's in there, we have a good.txt, and that good.txt is going to be extracted to the public directory, and we have some directory traversal, which is actually going to extract over the native to ASCII of our JDK. So if I was to cat native to ASCII, we're just going to echo out something saying gotcha, and that will appear as our title. Who knew you could do something like this in a zip file or an archive? I don't see a single hand. Interesting. So let's jump back and actually do this extract. So I'm going to click on upload files. I'm going to choose the zipslip.zip, wherever that is. That's going to be in Snick. Snick, Java Goof, exploits, and zipslip. Open this. If I upload this, then we see good.txt is in there, but what we've actually done is directory traversed out. We've broken from the target folder. We get the ... which when you get to root, when you do a cd ... from root, you stay in the root, and then it goes all the way back up to overwrite our native to ASCII. So now when I create a to-do, and I don't even need to add any ASCII characters here. I can just say, let's buy some milk. We're still going to go through that ASCII to a native to ASCII call, and when I call that, we can see that we've overwritten one of the JDK files. Now, normally, this wouldn't necessarily be possible because we'd add an amount of, add some, checking, making sure we're not the same user that has these kind of system files, interesting system files. But what you could expect to see is perhaps JavaScript being added into an application, and that when other people, try to access that application, they're executing malicious JavaScript which you created. So there's still a huge amount of pain that you can see. So this is zipslip. Zipslip is quite prevalent actually in a number of different libraries as well as the code yourselves. Because Java doesn't have a core zip library that allows you to extract, what we tend to do is we tend to grab a zip entry, we tend to iterate over an archive, grabbing zip entries and concatenating the target directory with the zip entry name, and then just concatenating that together without checking what the zip entry name is. That's exactly what the ZT-zip and a number of other libraries have done. And as soon as we concatenate that, the ... so forth reduces that and then builds up its own path. Okay, so let's jump to an ugly-looking application. This is called Goof To-Do app. Very, very similar in that we can add some to-dos. If we wanted to add a really important to-do, like let's buy beer, we can add stars, and what that's going to do is it's going to highlight the beer as bold because we have markdown support. I can remove these, I can do a whole bunch of other stuff, I can click on about, and we get some served content from the public directory, and I don't think it's the best to-do app ever, but it's pretty good. Now, this is our application. This is on the Snick GitHub pages. And what I've taken the liberty of doing already is I've gone into my integrations here from Snick. This is all free, by the way, I can show you. I'm going to add some projects. Depending on the Wi-Fi, I can just show you some spare pages. You can add as many GitHub projects as you want, and you can run a number of tests against those GitHub projects. What it will do is it will compare your dependency tree against a list of known vulnerabilities in the Snick database. The Snick database is an open source database which holds all vulnerabilities from CVE, NVD, and a whole bunch of other places. And it will provide you with a list such like this. If I was to go over to the, this is the Spring Goof, this is the Goof package, the NPM package, and here I can see a whole bunch of different vulnerabilities that exist on this application. Okay, this is an application which is designed to have vulnerabilities. So if I was to do a search for a package called ST, and I find the right vulnerability. This is a directory traversal vulnerability in this ST package. I'll tell you, the ST package allows you to serve content from a directory. I've told you about directory traversal already. Directory traversal is about the ability to break out of a target folder so that you can access other parts of the file system. So this is where it gets a little bit interactive. So how can we break the target directory and access files on this file system from what I've shown you in this application? Any ideas? No one. Really? Let me show you this again. Any ideas how we can break out of this directory traversal now? From here? Okay, we're going to pretend we are actually hackers, so I'm going to do it at the command line. If I type st1, we have a curl here. If I was to grab this curl and execute that, yeah, we get the about. So if I was to curl this, where would I put the dot dot slash here? Like that? Who thinks that's going to work? A couple of hands. So if you run that, what we get is actually the home page, because ST is a real life, a real world library, and it's recognized we're trying to do directory traversal. So we can't do dot dot slash because it's recognized the dots are directory traversal. So how else can we break it? Encode? Encode the dots. Do you know what the encoding is? No? It's probably because you have a life. I don't, so I know it's 2E. So this is the encoding for dot dot. If I run that, boom, we get our directory traversal. I can now, what can I do? I can just run this many times till we get to the root. There's the root. I can do that again, and this time perch slash etc slash password, and boom, there's my etc password. So directory traversal is a very good way of us traversing the current directory and trying to work out what's on the file system. It's a great way of trying to learn what's available and potentially find another way of breaking in. We can't necessarily remotely execute code here because all we're doing is reading from the file system. But this is a classic directory traversal. The next vulnerability I want to show you is this one. The next one I'm going to show you is one in marked. Cross-site scripting. Everyone's heard of cross-site scripting. This one is in the marked. This is actually a tricky one. I don't think anyone's going to get this one, but I'll show you, and it's going to be a bit of fun, actually. I like this one. So I'm going to go back to my to-do, this one here. We're going to run some cross-site scripting. So how do we run cross-site scripting on this application? Like this? No, you said it. Let's do it. No, that didn't work. Uh-huh. Oh, that's a good idea. I like that one. So a button, but let's do this one first, because this is what I've already started this one now. If we do this, this is the classic, okay? We want an alert. How exciting. If I run that, marked library is understanding that we're trying to get an alert. As a result, it's understanding we're trying to run some JavaScript, so it just says, no, I'm not going to run that. I'm just going to validate on the way in, validate on the way out. But because we're marked, we can do something like a button, okay? I'm going to, instead of a button, actually, I'm going to do, what's this conference? This is JBCN. Oops. JBCN. How about a link? It's very similar to a button, right? So if I was to run this, HTTP, what's the URL to the conference? Oops. Oh, well, that's good enough. If I click on that, we get a 404, because I typoed. Let's go back. So if I was to double-click this, JBCN.conf. And then if I click on that, then we get to the JBCN site there. So if I was to do this again, so JBCNConf, how would we do JavaScript here then? And on click. There's actually an easier way. We can just do this, because this is effectively a reasonable link. Anyone think this is going to work? Nobody. You're right, because marked has a whole bunch of validation. It actually doesn't have validation by default. If I was to show you, if I was to cat the dot, I think it's app.js, what we've actually done is we've actually added this annotation to be true. We've done this because we want to be a little bit more realistic as a production style app. So I can tell you that the bits it doesn't like is the colon, and it doesn't like the closing brace here. Any other ideas? In code? Okay, come on then. Any ideas? No, you shouldn't have. It's ampersand and I forget this one all the time. Let me check. I think it's ampersand and 58. Like this is a colon, and this is a closing brace. So, who thinks that's going to work? Oh, I've got a few hands now. Nope, didn't work. It's still recognizing that. If I open this, you can see it's actually converting it to the correct characters, and as a result, it's not working. Let me tell you this one, because this is a good fun one, and it's actually not a vulnerability necessarily in that library, but it's a vulnerability almost of the browser. Because what I'm going to do is, the browser's great because sometimes it says, I think I know what you're trying to do. Let me help you here. So if I was to type this there, what it's going to do is it's going to say, there is a semicolon after this, but I think what you want is a colon, because this is a perfectly fine command. And if I put a semicolon after that part there, then you'll get a colon. So even though this goes through the marked library, through the sanitized function of the marked library, because it's not a colon, the browser is actually going to represent it as a colon, because it thinks it's trying to do the right thing. So when I execute that, it's actually being shown as valid HTML. Now when I click that, of course, I'm going to get my alert. And this is now, anyone who goes to this is going to see that alert. So that's an interesting one where it's, the browser doesn't help. It actually hinders in this sense. Let me show you also one which is a RDoS one, a regular expression denial of service. Who's heard of these RDoS vulnerabilities? Not many people. Who uses regular expressions? Fair number of people. Who likes using regular expressions? Who likes reading other people's regular expressions? No one. Oh, one person, a masochist right at the back. Right, so a regular expression is an interesting thing, because regular expressions, of course, the way they work is they try their absolute hardest to find a match, to find a pattern that matches. If it can't find a pattern that matches, it says, hands up, give up, can't do it. But it will work through a string, and it will use a backtracking algorithm to try and find all possible ways of matching that. So if I had something like A plus and then maybe a star here, and I tried to match A, there are a number of different ways that can be matched. This might actually be perfectly fine to match just on A plus. However, it might provide, it might go, there are 6 of these, so it might do A plus, resolve that as a single A, and then use the star to say there are 6 of these. So there are a number of different ways this can resolve. If I put a B on the end, it's going to try and backtrack that. It's going to say A plus star. I can get all my A's, but I can't work out the B. I know, let's try and resolve the A's in a slightly different way, and then try and resolve the B. And it will continue to, a huge combination of, using the plus and the star to generate that set of A's before it will say, I can't find this B at the end. As a result, there's no match. Now, we can use this knowledge on redos to say, okay, what if I create a string, and let me type MS1. Yes, you must know what that is. Okay, what we're going to do now is we are going to echo this. There we go. We're going to echo this, and all that was doing was the content is just going to say call mum in 20 minutes. In fact, it's the US mum. Call my American mum in 20 minutes. And what we do if we come back here and refresh this is we get the MS library, which is the library which we're going to attack here. The MS library is going to do some pattern matching on that to say in 20 minutes is actually a time. I'm going to represent that as 20M in brackets. Now, if I wanted to be a little bit cheeky, and let's type MS2. What we can do here is we're going to buy milk in and then pass 60,000 instances of 5 followed by minutes. If I was to run that, it's actually not that far. It's actually not that slow. And the reason it's not that slow is because it actually finds a match very quickly. And as soon as it finds a match with that many number of 5s and minutes, as soon as it finds a match, it returns. But what we want to do, and if I go back just to show you that's worked, buy milk. Interestingly, it couldn't deal with the large number of 5s there. But if I come back and if I was to do that again, but this time I change from minutes to minute a. It's going to try its absolute hardest to match that. And it's going to go through those 60,000 5s many, many times and backtrack before it realizes it can't match that minute a at the end. As a result, when I run that, damn it, it worked. Why has that worked? Okay, I think I've upgraded to the latest version. Yeah. Say again? No, that's fine, because that quote there goes up to here. I think I'm actually just on the latest version of MS. I'll show you. I'll tell you what. I'll show you how to remediate, which is what I have clearly done with this earlier. But what that will do is that would actually hang that thread, which would mean that whatever I typed in here would hang for about 15 seconds or so. And if I was to add another 0 on there, it would hang for long enough for me to not have access to that. So what does that actually provide us with? Well, once you have a denial of service, unless you're using serverless, a denial of service will stop you effectively accessing that thread. If you are using serverless, then it's going to cost you quite a lot. So it's denial of pocket. So what else can I show you? I have about 6 minutes left, so I'll just show you how to remediate, and then if we have time, I'll show you 1 or 2 more. So to remediate, then, I've shown you how we can actually have reports like this one of Java, like this one of NPM, and we have these reports telling us what the vulnerabilities are. But one of the things about DevSecOps is the ability not just to know about them, but to be able to fix them, to put it into your developer flow. So one of the things we can do here is we can open a fix PR. So this is actually introducing the fixes into your developer flow. Hopefully if the internet's going to be good, here we have a list of the vulnerabilities. We're going to select them all because we're a bit rock and roll like that. We're going to fix them all. I'm going to click open a fix PR, and it's going to automatically send a PR to GitHub, which is going to provide all the fixes. So as soon as this gets done, internet's not too bad here, so it Should work pretty quick. There we go. Here's my fixed PR. I can click on the file changes. We've got a couple of patches working here, and we've also got a number of updates. So, for example, if I was to come over here, we can see Mongoose has changed from 4.2.4 to 4.11.14, and it sends you up to the closest version which has the fix in, because we don't want to push a much higher version because it could potentially have breaks in terms of your application. So that's how we remediate, and I've obviously remediated the MS library here. So let me show you another one. Let me show you, I know what we can show you. So I'm also going to show you another about page, which is this. It's a pretty cool about page. It's my new about page. But what I'm going to do is I'm going to add a device, and my device is going to be a desktop device. So here we can see this has obviously been rendered for a desktop. This was mobile. This was desktop. You see how good my CSS skills are now. But one thing we can do is, because we're passing in some text, one thing we could do is, if I was to come here, you can see what I'm going to do is I'm going to run this console log saying gotcha. I'm going to add this to the end of my call to see if we can actually add some remote code execution here. So I run that, and we can see we've got this desktop with the dashes. But unfortunately, if I come back and have a look at my log, although we're getting this printed out, there's no actual console log of gotcha, and that's because when we pass in a string, we recognize it's of type string. The libraries recognize it's of type string, and as a result, we recognize it's a string and make sure we do the validation on that string. Now, what if the type isn't a string? Any idea how we can pass in a type that isn't a string here? Anyone? If I do this, it actually turns it into an array. And when we actually pass this in, this is going to be flattened into a string anyway, but that flattening is only going to happen after the sanitization check. So we're going to see if it's a string. It's not a string, so we pass the sanitization check. We then flatten it into a string, and when I execute that now, did I execute that? When I execute that now and come back, I executed it twice, we now see it as an array, so we don't do the sanitization, and here's where we get the console out. So here we can do remote code execution as well. So this is actually on a library called Dust. So, one other thing I want to quickly show is, if I go back to my slides and play, got a couple of minutes left. One thing I want to talk about a little bit is something about your security considerations. So when we think about what we want to do to protect our application, there are 4 things here that are extremely important to think about: prevention, detection, response, and recovery. Prevention is typically what we think about when we want to try and secure our applications. How can we stop people from accessing our application and our data? Detection is an interesting one about how can we actually work out when someone has hacked us. How can we work out when someone has breached us? I think the Equifax example, Equifax were breached for over a month before they even realized a breach occurred. So detection in terms of trying to work out if hacking behavior is occurring on your machine, unusual activity in your logs, unusual network traffic, unusual disk traffic, perhaps the absence of logs, whereby attackers try and cover their tracks. One of the key things that attackers very often do is overwrite things like your ls file or your ps commands, so that when they try and include malware on your systems, you can't actually detect it, because you type ls in a directory, you can't even see the directories that they've added. When you type ps, you can't see the processes that are running that they are running. Response and recovery is more about how you respond, how you act internally, what processes you have to escalate the fact that a breach has occurred, and how you recover. How you recover is all about when your system is breached, how do you go back into production, knowing that your environment doesn't still have malicious code, malicious artifacts lying around. The key way of doing that is to do it back from source. So how quickly is it for you to go back to production with your backups? How quick is it for your infrastructure to be recreated? Obviously, if you're using a microservices environment versus something like a monolith, it's going to be a lot harder. There are also a number of other things which you need to think about and consider with your architecture and design security in. For example, if you're using microservices, what communication happens and what communication occurs between your microservices? If you're using plain HTTP, then perhaps you're open to something like a man-in-the-middle attack, because your communication can be sniffed, your messages can be augmented when you pass it across, all those kind of problems. So I'm out of time right now, so I'll jump to, let's see if there's maybe one or two questions I can take before we finish. Any questions? There's one up there. Or if you shout, I can repeat.
My first question is, or the biggest question I have in my mind is, how do you keep track? I mean, you started your talk saying that DevSecOps is about introducing security to DevOps.
Uh-huh.
Now I was trying to figure out, while you were explaining all that kind of exploits and also the many dependencies that you have and how deep in that dependency the actual problem is how do you can actually automate that?
Okay,
for me,
question.
DevOps is just about automation.
Yeah, so it's absolutely a superb question, actually, because DevOps, the thing with DevOps is you want a pipeline that executes quickly and you want a pipeline that can take you to production quickly. How do you add security into that? Well, the traditional tools, the traditional auditing just won't cut it, because auditing takes time, auditing takes specialists, and what you want is a level of automation that you can include into your pipeline. So there are tools available. I can show you Snick if you would like. Snick is a tool where it takes the manual checking away from the libraries you're using, the dependency graph you're using, it checks that automatically against a list of known vulnerabilities, and then provides you with information. So, from a developer point of view, if I'm in GitHub, I can run this automatic test like I just showed you, and I can see all the vulnerabilities that exist. Then I can do my remediation if I choose, but this is still a little bit manual because it requires a developer to do this. One other thing that we provide is a Snick CLI. So if I was to come over here and I were to be in this directory, I can maybe run Snick test. And what this is going to do is it's going to automatically provide me with the full list of vulnerabilities. There we go. So you can see there's a medium severity one there, and it goes up beyond that. Now this can actually be invoked during CI. So in your CI build, once you've built your application, you can then run this through it. You can also run a Snick wizard, which will automatically fix those points. But this command can potentially fail a build if you have new vulnerabilities that exist that are high or medium. You can set up that threshold. One other thing that you can do is you can run something called Snick Monitor. And Snick Monitor is something which is going to create a snapshot, and that will create a snapshot of everything that's in your runtime. And when you have new runtime vulnerabilities that now exist in your production environment but didn't when you built, that will do one of two things. It'll either raise a pull request against your repository to say a new vulnerability exists, you need to fix this, or it will just simply email you if you don't have like the GitHub kind of credentials. So these are the kind of tools that you can push in at the development level, and it actually exists in your development flow. So you can use this. I mentioned the first UI, that could potentially be done by developers. The CLI tool can be done during CI. There are also Snick you can use in containers, so it can provide that last level of defense so that when an operations person tries to deploy something, it'll stop you because it will say there's a high vulnerability here, you need to be an admin in order to push this into your container. And then post push, you would need to then take a snapshot, monitor what's in your production, so that if new vulnerabilities exist, it'll email you or send you a pull request. So those are the kind of ways which Snick offer that as an automated way in your development flow. There are other tools, of course, as well, which do similar apart from the remediation part. Does that answer the question? Yeah? Run out of time. Excellent. So thank you very much for attending. I hope you enjoyed the session.